Everyone watching the skies asked the same question: is 3I/Atlas heading for Earth? What began as what many expected to be a routine flyby turned into a chain of events that left astronomers, engineers, and mission teams scrambling to explain what they had seen. The object that passed Mars did things no natural body should be able to do. It did not simply skim past and keep going. It slowed down, matched Mars, and settled into a perfect circular orbit, a move that made scientists stop and recheck their data. When Atlas first appeared on radar and in telescopes, everyone expected the usual path, a fast visitor crossing the solar system on a long, lonely arc. Instead, it approached Mars at speeds reported to be hundreds of thousands of kilometers per hour, a velocity so high it would circle Earth many times in a single minute. Observers had planned to take quick measurements and then watch it slip away. What followed broke those expectations. Over a period measured in hours, the object decelerated from its interstellar speed and matched Mars's orbital velocity. Those breaking numbers read like science fiction on a lab sheet. To slow an object hundreds of meters across from interstellar speed to orbit requires energy on a scale humans do not command. Many news outlets and mission briefings noted the unusual nature of the encounter and the intense international attention it drew. Even more puzzling than the amount of energy was how quietly the object carried out its maneuver. Typical high-energy moves produce heat, clear infrared signatures, and visible exhaust. Observations during the slowdown showed very little excess infrared glow. Instead, observers saw focused blue-white emissions at points along the structure that looked more like controlled engine burns than scattered sunlight. Infrared detectors recorded temperatures barely above ambient space. That suggested a propulsion process far more efficient than anything humans operate, a system that turned input into thrust with very little waste. Engineers trained on rocket exhaust and expanding gases found the data difficult to reconcile with known propulsion systems. The idea of steady, low-level thrust lasting hours at such speeds without the expected thermal signature raised the possibility of propulsion concepts outside publicly known physics.
A congressman, Tim Burchett, was discussing deep underwater bases and underwater submersible objects, unidentified submersible objects. Like, it's crazy. Watch.
You received intelligence that suggests that there are perhaps deep water alien bases right now sitting on the ocean floor on this planet. Is that accurate?
I would say that's pretty accurate.
Spacecraft from more than one agency watched the event and recorded similar anomalies. The Mars Reconnaissance Orbiter captured the insertion into orbit in detail, and other orbiters recorded spectroscopic oddities. Some particle detectors picked up fleeting signatures that a few physicists suggested could match rare high-energy processes. If those early readings were correct, the implications were staggering because they hinted at energy densities far beyond what conventional chemical rockets or solar sails could produce. But analysts stressed the data was preliminary and needed careful cross-check and peer review before drawing definite conclusions. At the same time, high-resolution images and observational notes from ground and space observatories were being collected and compared to build a clearer picture. For readers following the official summaries and briefings, NASA and major news outlets provided regular updates.
Today, because the Mars rover just captured something nobody expected, a glowing tic-tac-shaped object streaking across the red planet sky, and it's being called 3I Atlas. It's an interstellar object heading towards Earth, and the images are unlike anything NASA has ever released. And at the same time, a sitting congressman is confirming reports of
Once Atlas was in a stable orbit, the pattern of its activity shifted from movement to study. Rather than circling passively, the object began to sweep Mars in methodical patterns. Instruments recorded pulses of electromagnetic energy that swept across the planet in geometric strips. Each pulse lasted only a few seconds, but was designed to penetrate deeply, like high-power ground-penetrating radar, and returned images that appeared to map subsurface layers. The signals came back with levels of detail that made many remote sensing experts compare them to an extremely advanced reconnaissance pass. This was not casual surveying. Whoever or whatever controlled Atlas seemed intent on seeing beneath the crust. News coverage picked up on the scans and published images and analyses as they became available. The scans zeroed in on regions scientists had long flagged as interesting. The Jezero Basin, where Perseverance searches for ancient signs of life, received repeated attention. So did polar areas where orbital radar has shown likely ice, and canyon systems that preserve Mars's long history. In some cases, the scan lines centered on odd underground geometry that earlier instruments had only hinted at. Planetary geologists said the level of targeting suggested either very advanced targeting systems or prior knowledge about where to look. That raised a question. Had Atlas studied Earth's published Mars data and used it to plan these scans, or did it carry internal information about Mars that humans did not yet have? The debate spread between teams in different countries as they compared records.
First thing, it implied that it came from outside the solar system because gravity cannot bind it to the sun. It was moving too fast for that. And the other thing is that the object was relatively big, possibly tens of kilometers, the size of
Then Atlas began to release smaller objects. Over a 2-day span, observers reported more than 20 detached modules descending to the planet on controlled trajectories. They did not behave like random debris. Each descended with active braking, altered its path during entry, and targeted specific coordinates. Several reached areas near suspected subsurface water, and a few touched down near where human rovers were operating. One landed close to a canyon system, considered a possible site of buried structures. The behavior looked like deliberate deployment rather than accidental jettison. Coverage from scientific blogs and specialist outlets showed tracking maps and descent paths as mission teams tried to understand what had happened. That is where the mystery deepened. After landing, many of the small objects vanished from all sensors. Thermal signatures disappeared, radar returns ceased, and visible imagery showed nothing at the supposed impact sites. The disappearance was not gradual noise fading, it was an abrupt cutoff across infrared, radar, and optical channels. One rover drove for days to a landing coordinate only to find no crater, no debris, and no soil disturbance. Scientists suggested a few possibilities. The object might have moved after touchdown, it might have entered a stealth mode that defeated human sensors, or it might have burrowed into the ground. Each idea raised new questions, and none fit easily with our current understanding of how matter interacts with sensing systems. Analysts published technical notes exploring sensor limits and possible error modes before reaching conclusions. The apparent emplacement of devices across Mars shifted scientific curiosity toward concern. If those small units were probes or drills, they might already be sampling subsurface pockets. Mars has a deep history of liquid water and conditions that could have supported microbial life. On Earth, microbes survive in boiling vents, in deep crustal rock, and in environments that once would have seemed impossible. If life ever began beneath Mars's surface, refuges could remain to this day. The idea that an unknown visitor might be searching for biological traces added urgency to astrobiologists' work and prompted new test plans for the rovers and orbiters. Some research teams called for careful, measured responses to avoid any chance of contaminating or disturbing potential Martian ecosystems. Science reporting covered these debates and the evolving consensus about caution and planetary protection. Humanity tried to speak back. NASA redirected parts of the Deep Space Network to transmit a simple, universal message to Atlas. The transmissions included prime numbers and basic geometric sequences intended to show intelligence without a common language. At first, there was no reply. Then Atlas altered its own transmissions. Instead of ignoring the attempts, it began to include elements that echoed human math, but in more complex form. Cryptographers and mathematicians described the exchanges as a kind of back and forth, where the responses included problems that were progressively more difficult. Some teams even said they detected encoded imagery that, when decoded by different algorithms, could produce maps or structural diagrams. The exchange felt less like a monologue and more like a test. Major outlets covered the exchange and published decoded samples as they were validated. One decoded sequence appeared to contain a three-dimensional map, not of our solar system, but of another star system, including orbital positions and apparent structures around one of the planets. Another seemed to show biological diagrams, nucleic structures that resemble DNA but with additional complexity. Interpreters suggested these might be either the visitor sharing its own biological blueprint, or images of life it had found, or studied. Most experts urged caution, reminding the public that decoding signals is complex and prone to false leads. Still, the mere possibility that an incoming object could send complex structural information changed how many in the scientific community thought about the encounter. Coverage across news sites and specialty publications compared different decoded patches and asked what they might mean. As more data came in, analysts turned to the question of motive. Why Mars? The planet's watery past makes it a natural place to look for signs of life or artifacts. Subsurface ice pockets and deep valley networks preserve history far better than the dusty surface. If a visiting intelligence wanted water, biological samples, or buried facilities, Mars would be high on the list. If Atlas was testing intelligence by giving increasingly complex math problems, that pointed toward contact. If it was placing devices and hiding them, that pointed toward surveillance or long-term observation. Any of those possibilities had big implications for how humans should respond. News coverage explored each scenario and reported the range of expert views without pretending to know the visitor's aims.
In the comments and give us a follow. So NASA's Perseverance rover has captured clear, high-resolution images of an interstellar object called 3I Atlas. The object appears as a glowing white cylinder gliding across the Martian horizon. It's smooth, it's bright, and it's perfectly shaped. And as you guys can see, they updated the images to have it look green. I don't know if that was because of the chemicals coming off of it or whatever. And many people online are calling it a Martian Tic Tac, comparing it to the craft U.S. Navy pilots encountered in 2004. And those Tic Tacs.
Then came speculation about where Atlas might go next. After finishing its Mars survey and deployments, the object changed course in ways that led some trackers to project Earth as a possible next point of interest. Several analysis teams offered windows in which a close approach to Earth could happen in weeks if Atlas chose a particular trajectory. Those estimates varied with assumptions about future burns or course choices. The uncertainty made planning hard. Government agencies and space organizations emphasized observation and readiness rather than alarm. They increased the number of eyes on Atlas, coordinated data sharing across borders, and asked the public to rely on verified briefings rather than rumors. Media outlets ran stories explaining how object tracking works and why small changes in velocity can lead to big differences in where a body will end up months later. Official sources repeatedly said that at the time of their statements, Atlas did not pose a confirmed threat to Earth. Planetary defense teams had to adjust their thinking. Protocols used for asteroids and comets focus on impact probabilities based on size, speed, and orbit. Atlas did not fit those boxes. Its controlled moves, targeted deployments, and apparently advanced sensors required new kinds of planning. The most concerning scenario was not impact alone, but a coordinated operation, mapping, deploying devices, and possibly marking targets. That could be harmless reconnaissance, or it could be preparation for return visits. Defense planners, intelligence analysts, and scientific leaders quietly discussed response options. Public statements remained measured, arguing for continued monitoring and international cooperation. Specialist media published breakdowns of those discussions and explained the differences between standard planetary defense and the novel challenges posed by a maneuvering object. On Mars, rovers and orbiters recorded brief electromagnetic interference during Atlas passes, along with magnetic anomalies and localized atmospheric distortions. Cameras picked up shimmering effects in thin air that looked like energy beams. Telemetry sometimes dropped briefly and then returned to normal. Engineers worked to rule out instrument glitches and planned additional observations to repeat the tests. The apparent interactions with instruments led researchers to call for extra caution in commanding rovers or preparing surface experiments that might interact with unknown devices on Mars. Specialist tech publications and scientific blogs reported on the technical investigations and the steps teams took to validate or reject various hypotheses. Back on Earth, the response had many layers. NASA and partner agencies increased tracking and data sharing. Cryptographers and mathematicians worked around the clock on deciphering the responses from Atlas. Planetary scientists rechecked archival data for signs that might explain what was now visible. And intelligence agencies quietly assessed whether any terrestrial actor could be responsible for the observed capabilities. Officials kept public messaging calm in order to avoid panic while insisting that transparency about what was known mattered for public trust. Major outlets published timelines, expert interviews, and explainers describing which facts were firm and which remained speculative. The human story threaded through every telemetry readout and press conference. Teams of scientists, engineers, and mission controllers worked long shifts, piecing together fragments of data. They argued over interpretations, ran simulations, and faced the uncomfortable reality that some measurements might point to technologies beyond present human capabilities. For many of those doing the work, the event was the most intense moment of their careers. The tension between the wonder of discovery and the dread of unknown consequences ran through private conversations and informal notes captured by reporters. Media profiles and human interest pieces highlighted the people behind the headlines, describing both their fatigue and their determination to get the science right.
Whatever timeline we're on is insane. I'm going to keep this running.
Can you go into more detail? How long have they been here? Where are they?
Well, I'm extrapolating all this with my East Tennessee vernacular. So we've got five or six deep water areas of our oceans. We actually know more about the surface of the moon than we do about these areas.
Throughout all of this, the situation remained fluid. Measurements changed, models updated, and new data sometimes contradicted earlier interpretations. The particle signatures that some said hinted at exotic energy sources required more confirmation. The decoded images and maps needed peer-reviewed validation. Some anomalies could still be instrument quirks, miscalibrations, or natural effects not yet fully understood. The scientific community urged caution and continued scrutiny, because one wrong inference could send the world down a false road. But the accumulation of strange, independently recorded facts, the controlled braking, the quiet thermal profile, the deep scans, the targeted deployments, and the responsive transmissions all pointed to an encounter that deserved close, careful attention. Policy briefings and scientific journals both urged measured responses. For the public, the episode showed how little humans know and how fast the unknown can appear. The watchwords among experts became transparency without alarm, careful study without hysteria, and preparation without provocation. Practically, that meant more coordinated observation networks, more open data sharing, and more simulations of possible responses. It also meant continuing to try to answer the questions hinted at by Atlas transmission. If those signals represented a test of intelligence, as some cryptographers believed, how humanity responded might matter as much as the object's next move. Comprehensive explainers from trusted outlets helped the public follow the steps scientists took and understand why the story unfolded the way it did. In the days after the Mars encounter, a single question dominated planning rooms and newsrooms: what will Atlas do next? The orbit it took suggested reconnaissance, followed by a pause and then a possible departure. Whether Earth would be next remained uncertain. Early trajectory windows showed a possible close approach in weeks if Atlas chose a certain path, but the object had already shown it could change course and perform energy-intensive maneuvers. If it wanted to come toward Earth, it could. If it had other goals, it might remain at Mars or vanish into the outer system. The unpredictability made planning hard, and that uncertainty became a major theme in press conferences and expert commentary. The most unsettling questions were about intent. Atlas listened when humanity spoke in math, and it replied with more complexity. It deposited devices and hid them. It scanned for water and buried features. Taken together, the actions read like methodical investigation, as if Atlas had a plan. Whether that plan included Earth remained unclear. For now, the world watched for more data, more decoded messages, and clearer maneuvers. Scientists kept working the signals, refining trajectories, and running models. The rest of humanity did what it always does in uncertain times: it looked up. For readers who want ongoing, verified coverage and official status updates, follow the major space agency briefings and trusted news outlets listed here. Read more from official and trusted reporting as you follow this story. NASA's science updates on Comet 3I/Atlas, AP's reporting on the close approach, Spacecom's explainers on how Mars and other spacecraft are being used to observe the visitor, The debrief's compilation of new images and Al Jazeera's verification pieces on viral claims.